We had two excellent presentations after lunch. So the evening session after the tea break, we have two presentations on transformational technologies, cloud computing session. The first speaker is Mr. CSR Prabhu, Deputy Director General, National Informatics Center, Government of India, making a presentation on transformational technologies and cloud computing. So before I invite the speaker, I'll just run through the bio. Deputy Director General, National Informatics Center, Hyderabad, is under the Ministry of Communications and Information Technology. Shri Prabhu Saab is responsible for introducing new and emerging technologies for various NIC projects. Prior to joining NIC, he has worked in various capacities with TCS, CMC, TES, and Tata Motors. He has plenty of teaching and research experience at the University of Central Florida, USA, and was a consultant to NASA, Cape Canaveral. Now I'll request Shri Prabhu to give this presentation. Mr. Prabhu, please.
Thank you. I really appreciate the ARC to invite me for this presentation. So let us start the disruptive technologies in IT. IT itself is quite emerging and disruptive, but within IT, there are a few emerging and disruptive technologies, and cloud computing is the first among them. The others being mobile computing and a few others like big data, sensor networks, and so on. Among these half a dozen emerging disruptive technologies, cloud computing stands first. And let us demystify cloud computing today. It is basically a metaphor used for internet. The term cloud is nothing but internet. So everything goes and comes from internet. It's like a black box. You can get anything from the internet, anything from cloud. You can get everything and anything like a service and not as a product to be purchased. The original concept in IT was you buy everything. You buy hardware, you buy software, you buy all kinds of things and you install them, then you become obsolete and then you buy again. Like in the morning, the previous session, the whole issue was on obsolescence. You buy and it becomes obsolete, you dump it again, you buy again, it becomes obsolete, without even using it properly. So what is the solution? One of the solutions is possible through cloud. That is, you don't buy anything. Your all facilities, infrastructure, software, platform, and any other thing also will be provided you as a service. It is like renting in a different sense, not physically but virtually. So let us understand what it is. And the technology which came before cloud and which was responsible for the cloud to come up was grid. When we say grid, we don't mean the power grid, though the word is taken from power grid. The word power grid indicates a network of power generating stations or power generating plants which are generating power, and an end user can draw as much power as he wants from the electricity outlet through a plug or switch and etc. without bothering about from where the power comes. Like for example, this power which is here, can anybody tell, including the management of this campus, from which power plant it is coming? Nobody can tell because it is part of the power grid and is being drawn continuously. So same logic was extended to computing. So if you can draw computing power as much as you want without knowing from where it comes and switch off whenever you want, that was supposed to be a grid computing paradigm. So there was also a utility computing paradigm, which is you don't buy anything but you rent. The difference between utility computing and cloud computing we'll see later. Cloud computing has its origins from utility computing as well as grid computing as well as autonomic computing, which is self-managed computing. But it is different from all the three. Next. In fact, it is opposite of some of them. In grid computing, as I said, computers are shared by the program. You submit a program which is very long or very complex. It requires, say, 100 computers to be used. The grid will provide you the power of 100 computers, actually, physically. It will execute the program on 100 computers and then return the results. That is the concept of a grid. There are many grids in this world. We have the NASA grid, and we have the IPG grid, and we have the today's news. You might have seen the Higgs boson particle is discovered. CERN, they have a grid. They were the first people to have invented the grid, and they were also the first people to have invented the internet itself. What is the difference between internet and grid? Internet is just providing you a connectivity. Internet is nothing but a network of networks. So it will link you up to any network in the world. It will provide you access, nothing more. It cannot allow you to share, whereas grid will allow you to share their resources. In the internet, I can access MIT's data on MIT's computers, but I cannot run my program on MIT's computers. In a grid, you can run your program on a remote computer. And you can have grids. There are many scientific grids, TerraGrid, and many educational grids. They're already there for more than 20 years. And I have written a book on grid and cluster computing. But now we also have the e-governance grid. If you have the All India network, which is NICNet, and we have the state-wide area networks, which are SWANs in all states, if they are integrated, then it will become a grid. Grid is nothing but a network at the physical layer, and there are other layers which make it call a grid through certain functionalities, like we have the rapid file transfers, replicas, and sharing, and grid SOA, service-oriented architecture. We have seen in the previous presentation that web services are being used in the power industry also. So web services are the core of service-oriented architecture, and service-oriented architecture over the grid will provide additional functionalities, including higher security and higher capabilities, which are not possible in the normal SOA. Next. So most grid solutions are based on an agent or a scheduler, which will batch up the job submitted, and it matches the specifications available in the resources with the specifications expected from the job submitted. And the server farms, which could be in a grid, could be as large as 10,000 servers. Now, you must be able to distinguish between a cluster and a grid. A cluster is a set of servers in a server farm all together, which are connected with a high-speed interconnection network, forming a supercomputer architecture. A supercomputer is a cluster. It can have, say, 10,000 servers. It is not a grid. Grid is geographically distributed. The servers in a grid are geographically distributed over a large area. It could be a local area network or a wide area network or a global network. Next. Grids lack automation, agility, and they require a mediator scheduler. Now let us see what is utility computing. It is more closer to cloud computing in the sense application storage and computing power and the network, they're all based on rent, utility payment. They just are used pay by the drink model, similar to electric grid service at home, and pay for extra resources when you need and dispose it off or retire when you don't need. So when you need suddenly a large number of servers you can get, and that is called elasticity, and therefore it gives better economics. Utility computing was there before cloud computing came, before virtualization came. It was based upon just renting computing power in a data center. Like Reliance Data Center offers certain rental space, disk space, or CPUs on rent basis. There is no virtualization, there is no cloud. This model is also available. It was there even before cloud came. Next. So let us examine the evolution of cloud computing. It has evolved over a period of time. It has its roots in application service provider and the concept of SaaS. Before cloud concept came, Microsoft offered what is called the SaaS, software as a service. Because all the software vendors started finding their software becoming very expensive, the end users like us cannot afford to buy. So what is the way out? The recession in Europe and USA. That was the main cause. Necessity is mother of invention. Next. So how do we get rid of the costs and almost make it free, if not very cheap? It's not free, but it will be very cheap. So that's how the concept of cloud computing came. It is much broader concept than just SaaS, but it is extension of SaaS. A lot of people think, I saw in the exhibition also, cloud means only SaaS. That means all software will be put in a central server and everybody accesses it, and that's the end of it. SaaS is only one of the aspects of cloud. You can have IaaS also. That is, instead of software, it can be servers which are shared, which are virtual servers. And instead of software, it could be a platform which is shared remotely, PaaS. And they can also have things like storage as a service. And in future, you can also have what is called knowledge as a service. I've given a paper on knowledge as a service concept. So everything as a service on demand without any waiting period, and the location of resource is irrelevant. This is a general concept. Any service can be there somewhere, and people will get what they want when they want, and they'll pay only for it. This has been done in the power industry for ages. People pay only for what they use. Nobody buys a power plant and keeps with them. But in computers, it was happening all these years. Now it is no more happening. No more people want to buy any software or hardware for themselves. It is dependent upon the network latency, because finally you are accessing through the internet. So your network speed will determine the performance of your service. If you have a poor last mile connectivity, you cannot expect high performance in the cloud. Next. So applications, that is in the SaaS model, software as a service model, they reside somewhere in the cloud. You don't even know where they are. And the developers can develop, deploy, and run. That can grow easily, like if they can use certain platforms or use certain softwares, like SAP you take. SAP now is available on cloud. You don't have to buy SAP. The other day, Lanco Power CEO was talking to the president. He said, oh, we are worrying about buying more SAP modules. We want to implement more modules. And I said, don't buy anything. It's available on cloud. And even Oracle is now being offered on cloud. Microsoft was the first to offer all its products. Don't buy anything. Of course, you all know Gmail. You are all using Gmail. Gmail is the first concept of a cloud-based solution, software as a service. It's not to be purchased. It is free. If not free, it will be nominally charged. So you can activate and retire resources. When we talk of resources, we are talking of infrastructure as a service, apart from software as a service. We'll go deeper into that. So without concern for the nature and location of the underlying infrastructure, infrastructure could mean servers, it could mean storage, it could mean anything. Without knowing where they are and why they are, what they are, you just ask, I want this, and you will get it. But you require only your end user client. Just as you have the plug in your room, you need a client on which you can get 100 big servers. Can you believe this? It's almost like magic. It's like a booth coming and sitting. Actually, it's not there. It's virtual, because those servers are actually virtual servers residing in the data center of the service provider. Next. So if you want to compare clouds and grids, they are actually opposite each other, because a grid assembles a large computing in power for a single program or a problem to be solved, whereas the cloud does the opposite. One server is split into multiple virtual servers, and each virtual server is made available to the end user. So clouds are based on clusters. So when you have a data center with a cluster of, let's say, 16 servers, you can multiply into, say, 1,000 or 500 virtual servers, and then make those virtual servers available to the users, end users. So clouds are largely cluster-based, though we can also have a grid-based cloud. And grids are built, as we mentioned earlier, so that individuals can get the most, if not all, of the resources in a single request. And middleware approach takes a federation as a first principle, because middleware is essentially in a grid. Like Globus Toolkit is a middleware for open source grids. Resources are exposed only bare metal. Virtualization was not there when grid technology came. Virtualization was the turning point for the cloud infrastructure as a service cloud, which came later. So we have two different architectures and approaches, grids and clouds. Next. So some of the myths, false myths, are that virtualization and cloud are same. They are not. Virtualization is essential, but not sufficient for cloud functionality, because virtualization simply provides you, like if you use a hypervisor like Zen, it will provide you a virtual server, nothing more. But cloud is a facility where that virtual server can be availed on demand from a remote user anywhere in the world. And it is not that clouds and grids are equivalent, they are opposite each other. And it is not that performance will be affected if you use virtual servers. Nowadays, in fact, nobody uses physical servers. Next. So there are many companies which are offering all kinds of cloud services. Amazon is the most dominant infrastructure as a service provider for public clouds. Anyone of you want to use virtual servers, you just have to access Amazon and you can avail any number of servers within few minutes or seconds for any period of time at a very low cost, something like 8 cents per hour. All these virtual servers are available to you on your client. And so also other companies which are offering, Microsoft is offering infrastructure also nowadays, apart from their softwares and their platforms. Citrix, VMware was originally a virtualization company. It says it operates cloud now. Basically, VMware was the first hypervisor. One of the professors in a university in America came out with a concept of hypervisor, which is a software which resides above the hardware and BIOS. If you think this table is hardware and this is BIOS, a little above that, and above that is hypervisor, and above that are the operating systems. So one hypervisor can support multiple operating systems. So those operating systems could be, some could be Windows, some could be Linux, and so on. Therefore, you have an illusion of multiple computers to the end user. Why all this has happened is because the hardware became very powerful. No application on this earth can use a full server. A full server is something like it can do giga cycles of processing in a second. No application exists which can really use all that. So most of the time servers are underutilized. Next, we find that 90% of the server is never used. So when you have a server unused, you might as well share with others. So that's how virtualization came in, and virtual servers started being used by remote users. So cloud anatomy is that at the bottom you have the infrastructure as a service. We have many companies like Amazon. EC2 stands for Elastic Cloud Computing. VMware, which is also offering infrastructure as a service. Microsoft Azure is the platform where Microsoft offers all cloud functionalities, both infrastructure and platform and software as a service. And IBM Bluehouse. And then we also have platform as a service like Google App Engine, Aneka. Aneka supports multiple paradigms of programming over .NET. It will support multi-threading, multiprocessing, and also our large parallel processing Hadoop kind of architecture. And then we have software as a service. The most famous successful story is Salesforce.com. For sales accounting package you don't buy, you just use it for a nominal cost. And even more successful is Gmail. Or you can have a payroll which could be software as a service. Multiple organizations can use the same payroll, though they have different payroll requirements. The same software will modify itself, and it adapts itself for multi-tenancy. Then only it can be qualified to become a software as a service in the cloud model. If it cannot do that, it cannot function as a cloud model. Next. So we have the infrastructure and storage at the bottom. We have platform and application services and clients who access this at the higher levels. The clients are, of course, the end users. Next. So at the bottom you see servers, storage, network, operating system. These are all the resources. And the middleware, cloud middleware, like you have Eucalyptus. Amazon has its own middleware. It offers these resources at the bottom to the individuals or corporations or commercials or government as end users. So clouds are based on private clusters, and We have already discussed these issues. A tiny fraction of the total resource pool is used by the individual user in a cloud. In the grid, it becomes the opposite. Next. Next, we have, I think you have gone back, yeah. Go forward, yeah. So why cloud computing started? Because data centers and servers were notoriously underutilized. Therefore, Amazon thought, actually Amazon was selling books, so they had a lot of data centers, a lot of servers, and sometimes they found those books are not being sold so much, lean season, so servers are remaining idle. So how to make money? So they came out with the concept of providing virtualized servers to a remote user who will pay for it. That's how the infrastructure as service cloud came. And Gartner, Foster, and IDC all agreed that this will be the best business model for small and medium businesses, SMBs, and enterprises as like, because SMBs don't want to buy any hardware, don't want to set up data centers. And enterprises have already set up data centers, but they want to reduce costs, don't want to buy new hardware. After switching over to cloud computing, enterprises don't buy any new hardware, and SMBs don't have to buy at all. So cost will be drastically reduced. There is no new technology paradigm except hypervisor and virtualization and remote provisioning of virtual servers. All others are low technology solutions, because web-enabled software was there even earlier. It is the usage paradigm, or it is a business model which made the substantial change. Next. So public clouds and private clouds. Public clouds are opaque because you don't know where is it, what is it. You just have to blindly trust the service provider and use it. And many of the advantages offered by public clouds appear useful for on-premise IT. And what extensions and modifications are required to support a wider variety of services or applications. We need mobile devices interfaces. Nowadays, we have a lot of mobile applications in the cloud. You can download, as you know, or you can access without downloading. Please don't think that cloud means downloading. Downloading is an old concept. In cloud, you don't download anything. You just use it, because you don't have to download. It's all there readily, and you can use it. Next. So the characteristics of cloud computing are agility, that is on demand, elasticity, linearly scalable, that is from one server to 100 servers you can switch in 5 minutes and come back from your client. And it is SLA driven, multi-tenancy. I already spoke about multi-tenancy. Any software can qualify to become a SaaS model of a cloud if it is having the multi-tenancy functionality. And virtualization I already talked. Next. So this is the difference between a private cloud and a public cloud. In a public cloud, you see that the enterprise is having its own firewall, and it will protect its resources within the firewall. And public cloud is outside the firewall. It is like Amazon or Microsoft providing. And hybrid could be partly enterprise and partly from the outside world. Next. So public clouds are used by general public. They exist beyond firewall. Individuals, corporations, others use. And Amazon is one such example. Google Engine, App Engine is another example. But you have to be prepared for security and other issues, reliability, concerns. Like if Amazon goes down, it went down once, then everybody kept quiet. They couldn't do anything. Just nothing. Next. So large-scale infrastructure available on rental basis, virtual infrastructure, not physical infrastructure. And operating system utilization with them. As I said, hypervisors, Zen, KVM, Hyper-V, these are all various hypervisors. And now there's what's called overlay network. Previously a network was connecting, let's say 2 points, and this is a wire I'm connecting, one server here and another server here. But if I have 5 virtual servers here and I have 5 virtual servers here, one line is there, then how am I going to connect? There should be 5 connections. I have only one line. So they are called overlay networks. There will be virtual networks created. Next. So private clouds are within the boundaries of the organization, and all the advantages of public cloud, but the cost will be higher, but the benefit will be fine-grained control over the resources. Security is your own responsibility in a private cloud. Reliability is 100% because it is in your hands, and regulation can be met because it is in your hands. So large enterprises will prefer private clouds. And small business, medium business, and students and academic, they will prefer public clouds. And NIC is providing a private cloud on its own data centers. We have 35 data centers in 35 states, and we have 6 national data centers. Next. So service-oriented architecture on cloud is another paradigm which is close to SaaS, but assuming there are web service repositories on the SaaS model. Next. So developers need not buy any servers. They can acquire, deploy, configure variety of virtual servers and perform development, testing, and prototyping and product testing without buying any servers. Next. So open source. In any technology, you have in software, you have a private software that is proprietary and open source as two alternatives. So open source cloud infrastructure has also come up in a big way, as in competition to next Microsoft and IBM. Next. So Amazon and Microsoft face challenges from open source community. So the Globus community, which was a grid community, has extended itself into virtualization and cloud functionality with what is called Nimbus. And in Nimbus, every web service is a virtual server. And you have projects called Anomalism, Reservoir in Europe. Next. And we have the Eucalyptus, which is what we have selected for NIC. Eucalyptus is a company based in Santa Barbara in California, near Los Angeles. And they provide a software which will provide you virtualization, virtual servers, remotely accessible from anywhere on any cluster of physical servers. So you can have open source version which is free of cost, or you can have the enterprise edition which is charged. And it supports open source virtualization hypervisors like Xen and KVM, and also Microsoft hypervisor like Hyper-V. Next. So RightScale and Canonical, these are the other different cloud platforms, client tools as SaaS. Next. So open source cloud anatomy is that the client side interface is the same. They have standardized on the Amazon's same interface for all products. Eucalyptus also provides the same interface. That is what is called AWS, Amazon Web Services Interface. And next, issues are security and reliability. And sometimes private clouds could be hybrid clouds because you don't have adequate resources within your own data center, so use public cloud functionality. Customer SLAs allow applications to consider cost as a first-class principle. Now you can go for very, very low-cost deployment of cloud functionality, and it will go down further. That is for sure. Next. So as I said, the open source cloud platform, we have Eucalyptus on the infrastructure as a service, which is equivalent to Amazon from the front-end interface client tools. And we have AppScale, Google AppScale on the platform as a service. Both are from University of California at Santa Barbara. Next. I was there 2 years back. This is the internal architecture of Eucalyptus software, which we have deployed in our government data centers. So the servers are clustered into, go back to the diagram. Yeah, sorry. So you can see that the nodes are the servers which are controlled by node controller, and the cluster of servers is controlled by cluster controller, which are all softwares, and the cloud control controls all of them. And Amazon EC2 is standard interface for the client-side API. And from anywhere in the world, from any client, you can access virtual servers from anywhere. Amazon also has same technology. Next. So we have other, as I told you about hypervisors, Xen, KVM, VMware, Hyper-V, these are the hypervisors. These are useful for IaaS. Hypervisors virtualize CPU, memory, and local device access as a single virtual machine. And IaaS cloud allocation is set of virtual machines, or set of storage resources, or private network. Next. Allocation is atomic, and SLAs are offered. So there were two major questions. What is the performance impact on virtualization? whether virtualization reduces performance. This is a question which has been discussed in many forums. And impact of cloud infrastructure on performance. So the answer is that only for those applications which require high transactions throughput, like banking applications, ATMs, you should not use virtualization or cloud functionality, because I/O processor in the server is not virtualized. So the traffic in the transactions, I/O, will be affecting